Today we're going to be looking at a sample of roller coasters from the United States. We have 157 roller coasters to look at right here in this table. There's a few interesting things about this table we can point out. First of all, we have a lot of different attributes we can look at: inversions, duration, length, max height, year open. Today we're going to be looking at the top speed. Okay, and we're going to look at the top speed compared to a couple of things. The type of roller coaster, so wooden versus steel, and its age. So sometimes we're going to look at the year open, but more often we're just going to look at these age groups. So if I click on this older group, I've got a group of 31 roller coasters all built before 1980. Okay, and then if I click on recent, I have roller coasters built between 1980 and 2000. And my newest roller coasters are built after the year 2000. Right? So we're going to be comparing all of these roller coasters, and our big question is, are roller coasters getting faster over time? All right, so before we get started with that, we're going to look at the standards and goals that we've set for this investigation today. Over here to the right, you can see our mathematical content standards. So we need to represent data with plots on the number line. Today we're going to specifically use dot plots and box plots. We're also going to use statistics appropriate to the shape of data distribution to compare center and spread of two or more data sets. So we're going to look at the interquartile range, the median, the mean, the standard deviation. We're going to talk about what is different about these sets of data. And then we're going to interpret those differences about the spread and make some claims about the age of roller coasters and the top speed. In doing this task, we're going to have some mathematical practices emerge. We're going to be reasoning abstractly and quantitatively using numbers and our critical thinking skills. We're going to be constructing arguments and critiquing the reasoning of others using our data. We're using our data to make claims. We're modeling with mathematics, and we're using appropriate tools. The tool today that we are using is CODAP. It is developed for students to explore statistics dynamically. So let's get started doing that. I'm going to hide this text box, and behind it I've got a few notes, but more importantly our questions we're answering. So first we're going to answer the question is, are there any differences between the top speeds of older, newer, and more recent coasters? We're going to explain our answer. So there are some differences, and we're going to look at them by opening a graph here. This graph is going to open up. Okay, I'm going to make this bigger so we can see it. And on this graph, I am going to graph top speeds first. You can see these selected points are the points that I still have selected in my table. I think I have the newest group's points. So there's still, you can see the newest points there. I'm just going to unselect those right now. And we can look at this data and just see for ourselves, a lot of these roller coasters are going 50 miles per hour at their top speed, and they're kind of ranging between 50 and 65, it looks like. Okay, so that's pretty interesting. I like to keep that in mind. That is the center of our data, 50 to 65. We could add some movable lines to these, 50 to 65. There's 49.9, that's close enough. And then, yeah, so there's the center of our data, or what we think is the center of our data. We're going to do some things that prove us right or wrong about that. First, we're just going to split this data up into age groups. I'm going to drag it over here on the x-axis, and now we can look at it. Older at the top, recent in the middle, and newer on the bottom. So what I'm seeing right now is that we've estimated our center of the data for our recent roller coasters to be pretty much right on point. For our older roller coasters, that's actually the high end of the data. It looks like the upper 50%. And for our newest roller coasters, looks like the lower 50%. So what I'm going to do now is remove these movable lines, and we are going to graph the box plots and see what we see. And what we do see is that older coasters are slowest, and they range from 23 to 65 miles per hour, while newer coasters are ranging from 35 to 120 miles per hour. So their low speeds, it's pretty close, but their high speeds, their top speeds, it's almost double when you get to this newer roller coaster. instead of using the mean, I'd like to use the median here and highlight that real quick. The median speed of roller coasters is increasing over time. So we could definitely say that roller coasters are getting faster as they're being built now. But we can still see that the spread of this data, is about the same there. So maybe roller coasters are still going slow, but their top speed is definitely increasing. They still have the ability to go those slow speeds. Think of kiddie roller coasters, things like that aren't quite as big as maybe these coasters with a lot of inversions and stuff. But yeah, we're definitely getting faster, and I think it's really interesting to point out right here, 75% of our newest coasters are faster than 55 miles per hour, but 75% of our older coasters are slower than 55 miles per hour. So we've definitely made an increase in speed for sure. The other question we're asking is, does the type of material make a difference? So what we're going to look at is we're going to just drag type and replace that with age group here. Well, we're still comparing speed, but now we're looking at steel and wooden coasters, and if you are interested in it, because I think it's very interesting to color this by age group as well. So you can still see that each age group is represented here in both wooden and steel coasters, but in steel coasters we have a lot more of those new and recent coasters. So some things that are interesting about steel, I would like to add the mean here and talk about what happens when we get rid of it. When we get rid of these outliers, what happens to the mean? So if you look right here, what I'm going to do is select this point. It is selected now. It's an outlier. This wooden roller coaster only goes 25 miles per hour. It is an older coaster, but what we're going to do is hide it. And look what happens with that mean. It caught up with that median. Right? So we're going to do the same thing on this side. And this is actually going to move the mean a little bit lower. And we're going to do the same thing here. So this is just allowing us to look at our means of our data. And it actually represents the middle, excluding those outlier values. So in general, the average speed of steel coasters is faster, but the range and variability of these steel coaster speeds is also much larger. So 5 miles faster than the wooden coasters steel are, but there's not a huge difference. Both data sets have a pretty equal distribution above and below the average. So if you look here in the middle, you can see it really is this looks like, a really even spread for both wooden and steel coasters above and below the average. For all coasters, we can expect for both wooden and steel coasters for 75% of them to go faster than 50 miles per hour. So for the majority of roller coasters you get on, the top speed is gonna be 50 miles per hour, or faster. All right, so that's for the majority of roller coasters. But going back to steel, we're looking at this big range, probably because material science is telling us that steel has a higher stress tolerance, and it's definitely going to contribute to this wide range of speeds that the steel coaster can reach and travel at consistently. So our final question is, if we were going to ride a roller coaster built before 1980, what would you expect for a typical top speed? So I am going to put, I'm actually going to put my age groups back here so I can just I'm looking at before 1980. So I'm just looking at this age group, top speeds, all right, for older coasters. So I would not expect this coaster, any coaster built before 1980, to go faster than 65 miles per hour, because none of them in this data set do. It would probably travel around 50 because that's the median here. I would expect it definitely to go between 45 and 55 miles per hour in general. So we're going to go back to showing all these cases, and a newer coaster, so right here, we would expect that coaster to go faster than the older coasters, definitely. All right, so thank you, and I hope you have a great day.